Now we have reached the final stage. This stage is in the seventh step. Once we identify the address for the page table entry, we can calculate the physical address. Let's know if we perform the bit shift operation 2 times, we can have the physical address. As you know, the page table entry consists of 2 parts of the data. So in order to remove the bit field, we need to perform the bit shift operation by 10 position. So this operation can be seen in the pseudo assembly instruction. Later, this output value, the D0 register, can be left bit shifted by 12 position. As a result, we can have the physical address for this virtual address. Important point to understand is that, so in the layout of virtual address, offset value that is placed in the 0 to 11 bit position. So this offset is directly coming from the virtual address. This arrow indicate this operation. And then actual physical address is come from the page number that is placed in the last level page table. So this arrow indicate that this is the task. So here is the example address that contains offset. So in the 0 to the 11th bit position, so there are this kind of binary value. But this binary value can be converted into hexadecimal format. This is 0x280. Since this is the only offset, it does not affect address translation. So as a result, if we combine the 2 information, first one is offset value that comes from the virtual address, just like this. 280 comes from 280 from the virtual address. And another information is the physical address of the virtual address. This part comes from the PPN in the last level page table. This is the final stage to translate the virtual address into physical address. Until now, you got to know how the virtual address can be translated into the physical address. I believe that we have the 2 perspectives to understand this operation. First one is to understand how the virtual address is translated. So we go through each step to see how the virtual address can be translated, to see how to find out the address for each page table. Then you could calculate the offset information based on the 2 level index. But another important perspective is to identify how the page fault occurs during address translation. So for this, we need to understand more about the flag inside page table entry. Then we need to understand how the page fault occurs with different picture. This is the different view of how the virtual address is translated. We only focus on inside the logic that allows virtual address translation. But once virtual address is successfully translated, the controller is moved to the cache to patch the data. But if the page fault occurs, memory overload occurs, that results in the exception in RISC-V architecture. In the next lecture, we will dive into more about how the page fault occurs during address translation.